another Mission Management Suite tutorial. Today, we're going to be running you through the optimization feature. So, as you can see on the screen, what I have here is I have an initial elliptical orbit. So what we're going to do is we're going to take from this initial orbit and create it into a large circularized orbit, roughly in the geo range. So as you can see here, we have a single spacecraft and we have initial orbit propagated to periapsis. So what I'm going to do is I'm going to add the optimize function, and you can see here that optimize1 has been added to the tree. So I'm going to rename this, and I'm going to change this to increase RMAG. Great, okay. So the next thing I'm going to do is I'm going to go into the vary function. I'm going to make sure that the delta Vx is selected. I can leave these variables for as they are for now. Impulsive burn, what I'm going to do here is I'm going to change these all down to 0. What this will do is let the differential corrector actually choose these values for us if they've been specified in the vary. I'm going to link this to our spacecraft, so the burn will be applied to that spacecraft. I'm going to go into the propagate, and then I'm going to link this as well. And we're going to choose to go to Earth apoapsis, so the furthest point from Earth in this orbit. So now I'm going to select what we want to achieve. So link this to SLV1 again. And you can see here we have selected RMAG. At the moment you choose from RMAG, eccentricity, or inclination. And at the moment I'm just going to choose the RMAG to be 42,165. As I said, roughly in this geo range for the time being. Okay, great. So if we run this mission for now, what you can see is that I've kind of increased the time, the speed of the propagation here as well. You can see that our mission now reaches this new RMAG value that we set for it. Okay, great. So now we've got to this, the furthest point we want to get it from Earth. What I now need to do is circularize the orbit. If we propagated this further, all this would do is just create this large elliptical orbit. So let's add our second optimize function. And I'm going to change this to circularize orbit. Great. Okay, and then all I'm going to do is the same again. Make sure delta Vx is selected. Choose the impulsive burn to be linked to our spacecraft. Change the x, y, and z values to 0. And then for this one, I am going to choose a duration in hours of about 24 hours, roughly the orbital period of a geosatellite. And what we're going to do here for the achieve this time, is once we've linked it, is change the eccentricity to 0. And because we're only setting 0, I'm also going to change the tolerance to about 0.01 to really make sure we achieve, or close as we can, to this 0 eccentricity. Okay, so now I'm going to hit run mission again. And what you'll see in the timeline is that we now, the mission has been extended. So you can see we now have this second burn and this 24-hour propagate series we have down the bottom. So let's increase the speed of the mission now. So as you can see, we have our initial orbit, we have our orbital raising maneuver, and we then move into circularizing this orbit to give it eccentricity of 0 at about 42,165 kilometers. So there you go. As you can see, carrying out Hohmann transfers within MMS is incredibly simple and incredibly easy, along with a wide range of other things you can do with the optimize feature. So keep an eye out on what we'll be releasing in the coming months, as we'll be implementing new optimize functions, such as lunar trajectories and constellation optimization as well. Thanks for watching this video, and look forward to seeing you in the next one.